Okay, let me do another two examples. Um, this problem says find the tangent line approximation t to the graph of f at the given point. Use this linear approximation to complete the table. Round your answer to 4 decimal places. Here the function is fx equals 10 over x squared, and this is the point a and f of a. So given a equals 5 and f of a equals 2 over 5. So to write down the equation of the tangent line, according to the definition, the equation of the tangent line equals f of a plus f prime of a times x minus a. So that is that is 2 over 5. Okay, now to find to know what is a f prime of a, first we're gonna take the derivative of this function. So its derivative is negative 20 times x to the power of negative 3, which is negative 20 over x to the third. So f prime of a equals negative 20 over 5 to the third, which is negative 20 over 125. And they have a common denominator 5. So after we canceled out, it is negative 4 over 25. Therefore, the answer is tx. The equation of tx is 2 over 5 minus 4 over 25 times x minus 5. Okay, then the problem wants us to evaluate the function when x equals these values, and then to evaluate the the function to evaluate the x at of the function tx, so we can compare the actual result and the estimate value, like when x equals 4.9, f of 4.9 is around 0.4165, because we are asked to around 4 decimal places, so it's 4164. Sorry. This is the real value. The estimate value is 0.416. Let's try another. At 5 At 5, the function value is 2 over 5, because this is what we are given. And the approximation is also 0.5, is also 2.5. At this point, the estimated value is the same as the actual value. The reason is if we take a look at the function of tx, when x equals 5, the second term will be 0, right? Because we have 5 minus 5, 0. Okay, let's try another. At 5.01, at 5.01, the real value is 0.3984. And the estimate value is 0.3984. So by looking at this, the real value and its estimate value, we can see they are pretty close, right? This is because the value we wanna estimate the function, like 4.9, 5.01, these points are close to the close to 5, right? Okay. Then let's take a look at this problem. So here we're given the graph of this function fx, and we want to estimate the function value when x equals 1.8 and 2.07. So we choose the point A to be 2, and we're given the function value when A equals 2. So that is 1. And at this point, 2, 1, we draw the tangent line. So this tangent line is our Lx. Therefore, to estimate these two numbers, we just need to find out what does L of 1.8 equal, and use that to approximate f of 1.8, and find out what does L of 2.07 equal, and use it to approximate f of 2.07. So this will require us to know what is the equation of Lx, because we know the point 2, 1 is contained on Lx. So the only thing we need is the slope of this straight line. Now in this problem, since we are not given the function fx, so we are not able to use calculus to find the derivative and then find the slope. In this problem, we're using another way to find the slope, which is on the graph. We can see that this straight line, it contains the point 2, 1, and also it passes the point 4, 0, and the point 0, 2. So using two of these 3 points, we can determine the slope of this straight line by using this formula. Okay. Let's say if I use these 2 points, 2, 1 and 0, 2, so the slope is 1 minus 2 over 2 minus 0. which is negative 1/2. Okay. So then we can determine the equation of Lx, which is y minus 1 equals negative 1/2 times x minus 2. If we simplify this, this is a plus 1. So Lx equals 1/2 x plus 2. Therefore, when x equals 1.8, which is negative 0.9 plus 2, 1.1. So f of 1.8 is around 1.1. And when x equals 2.07, so that is 0.965.